We have talked a lot about the containers. Now let's look at the iterators. There are 5 categories of iterators. The first one is random access iterator. With random access iterator, I can access the elements in a container randomly. So if I add 5, the iterator will be advanced by 5. If I subtract 4, the iterator will be moved back by 4. I can also compare 2 iterators to see which one is in the front and which one is in the back. I can increment the iterator, I can decrement the iterator. One thing to note is the pre-increment is usually faster than post-increment, because the pre-increment doesn't have to return the old value, which is typically stored in a temporary variable. Vector, deque, and array provides random access iterators. Second category is bidirectional iterator. With bidirectional iterator, I can increment it, I can decrement it, but I cannot add or subtract a value to it. I cannot compare 2 iterators. And here are the containers that provide bidirectional iterators. Basically the list plus the associative containers. Third one is forward iterator. Forward iterator can only be incremented. It cannot be decremented. And forward list provides only forward iterator. So what containers have we left? The unordered containers. Unordered containers provide at least forward iterators, but they have the option to provide a bidirectional iterator. It depends on the implementation of the STL. Number 4, input iterator. Input iterator is to read and process values while iterating forward. You can read from a dereferenced input iterator, but you cannot write to it. Output iterator is to output values while iterating forward. You can write into a dereferenced output iterator, but you cannot read from it. Both input iterator and output iterator can only move forward. It cannot move backward. So it provides a subset of the functionality of a forward iterator. Every container has an iterator and a const iterator. In this example, the set of integer has a nested class of iterator and another nested class of const iterator. Const iterator provides a read-only access to the container's elements. So here I use citer, which is a const iterator, to iterate through every item in my set and then print it out. If I try to modify the element, it won't compile. C++11 also provides all the containers 2 additional functions to access the const iterator, cBegin and cEnd. Those 2 functions provide a convenient access of the const iterator to the algorithm functions. In this case, the algorithm function of for each will call my function on each element in my set. And my function can only read elements in my set. It cannot modify elements in my set. STL also provides some functions for iterators. One of them is advance. Advance iter 5 will move the iterator forward 5 items. For random access iterator, this is equivalent to iter plus equal 5. However, this is a convenient function for all other iterators. Distance measures the distance between 2 iterators, and again, this is a convenient function for non-random access iterators. Iterator adapter or predefined iterator is a special kind of iterator that does more things than just iterating. There are 4 kinds of iterator adapter: insert iterator, stream iterator, reverse iterator, and move iterator in C++11. First, insert iterator. I have integer vector of vec1 and vec2. Then I use the function find to find the element of 16 in vec2 and store that location at the iterator of it. Then I create an insert iterator, iter, which points to vec2 at the position of it. Now I do the copying. I copy everything in vec1 to iter. As the result, everything in vec1 is inserted before 16. This is how the insert iterator works. There are two other types of insert iterator. Back insert iterator insert at the back, and front insert iterator inserts at the front. Second category is stream iterator. Stream iterator is to iterate through the data to and from a stream. Here I have iStream iterator of cin. This will iterate through the data that comes in from standard input. The default constructor of iStream iterator represents the end of a stream. Back inserter is a function that returns a back insert iterator. In this case, it returns a back insert iterator of vec4. So what this code does is it copies everything from standard input and back insert into vec4. I can also copy everything inside vec4 to ostream iterator of standard out, cout. So everything in vec4 is printed out at standard out, and each element is separated with space. We can even combine these two statements together into one statement, like this. This demonstrates the power and flexibility of standard library, how one line of code can achieve complicated things. Reverse iterator is to traverse a container in a reversed order. Here I created a reverse iterator of riter. STL provides every container two additional functions for reverse iterator. One is rbegin, which points to the last element in the container. rend points to the element before the first element in the container. So this is how we traverse the container in a reversed order. And the printout is 7654. Now let's look at the algorithms. Algorithms are mostly loops. So whenever you see a for loop or while loop in your code, you should seriously consider replacing them with a function call from algorithm. That will make your code more efficient, less buggy, and more readable and more clean. There are lots of algorithm functions in STL, and I don't have time to cover all of them. So instead, I'll talk about things that are generally applicable to all algorithms. Here I'm calling a function minElement, which will search and find the smallest item in vec. So in the end, iter is pointing to 1. Algorithm function needs to know where is the data that the algorithm should work on. And that data oftentimes is a range of data represented by a pair of iterators. So the first thing to note is algorithm always process ranges in a half-open way, which means it will include the first item but not include the last item. So here when I call the function sort on vec.begin to iter, vec.begin points to 4, so 4 is included. Iter points to 1, so 1 is not included. So the range of data that will be sorted is 4 to 5. So the result is this. Now I call the function of reverse on iter to vec.end. Iter is pointing to 1, so 1 is included. Vec.end is pointing to the item after the last item. So the range is 1, 3, 9. So the result is this. And at the end, the iter is not pointing to 1 anymore. It's pointing to the old location where 9 is located. Note 2. Sometimes a function needs not only one range of data, it needs two ranges of data. In this example, I have a vec2, and I copy everything from iter to vec.end into vec2. Here, the first range is represented with 2 iterators, like usual. But the second range is represented with only 1 iterator, which is pointing to the beginning of the range. The end of the range is inferred from the size of the first range. So one thing we should remember is the second range should have at least as many space as the first range. In this example, vec2 should have at least 3 elements. Otherwise, the result is undefined behavior. So this is an example that STL sometimes will sacrifice safety in favor of efficiency and flexibility. So we need to be careful when you use this kind of function. To overcome the safety issue that we've just talked about, STL provides insert iterator. Here I'm calling backinserter, which is a function that will return a backinsert iterator. Backinsert iterator will do inserting instead of just overwriting. So even though vec3 is an empty vector, the copying will be performed safely because every item from iter to vec.end will be inserted at the end of vec3 one by one. Although the backinsert iterator is safe, it is not efficient because it only inserts one item at a time. So do we have a function that's both efficient and safe? For that, we have to use vector's member function insert. We insert everything from iter to vec.end at the position of vec3.end. This is both efficient and safe. It's efficient because it only inserts once. So this demonstrates that STL often provides many ways of doing the same thing, and oftentimes there's only one best way to do it. This is the kind of trick that we'll talk about more in the future video. Note 4. Algorithms works very well with functions. Here I define a function isOdd, which tests if an integer is an odd integer. And then I can use findIf to find the item in vector that satisfy the condition of isOdd. So in the end, iter is pointing to 5. Note 5. Algorithm can even work with native C++ array. Here I have an array of 6, 3, 7, 4, and I can use the sort function to sort the array. Sort array plus 4. This can work because a pointer can be think of as an iterator. Iterator is a pure abstract concept. Anything behave like iterator is an iterator. And in this case, a pointer is an iterator. That's all for today. Thank you for watching. Feel free to subscribe to my channel so when I post a new video, you will be updated. Or you can go to my channel's homepage and see what I'm offering today. Bye bye.